So we're going to go through a few conceptual questions regarding pendulums. Again, these are multiple choice, so make sure you answer on your own first, and then watch the solution and make sure you understand the concepts. So the first question right here, what do you think about this? The correct answer here is C. The mass does not affect the period of a pendulum, at least not in an ideal pendulum where we're talking no thermal energy is created. So our simple pendulum, omega is the square root of G over L. We know omega is always 2 pi f, which means it's also 2 pi over T. The period of a simple pendulum would be 2 pi times the square root of L over G. It is the length that affects the simple pendulum, the period. Now G does as well, but I don't have control over G to change that for you. So changing the mass is not going to affect the period. All right, here is another question. What do you think about this one? So let me walk through this one, make sure to reason it through correctly. So with the previous question, we found the period of a simple pendulum is 2 pi times the square root of L over G. So G in this case is half as big, which means we could write this as square root of 2L over G. If I factor out that 2, and technically the square root of 2, that leaves me with the square root of 2 times the original period. So D is the correct answer here. Let's look at another question. All right, so let's walk through this. So period, a grandfather clock is a physical pendulum. So the period ends up being 2 pi times the square root of I over mgl. Essentially, it's related to the length of the pendulum over G, similar to the simple pendulum. If you want to reason this through, go back to the example problem for the meter stick as a pendulum, and you'll see that our equations simplified down to depend upon the length in G. It's not equal to the square root of L over G, but it simplifies to depend, those are the variables. So here, our antique grandfather clock is running too fast. That means the pendulum's swinging back and forth too quickly. So the period is too small. So we need to increase the period. To increase this period, we cannot affect G. We can only change L. So if we want to increase the period, we need to increase the length somehow. So A, we don't want to shorten the pendulum. Hanging something off the end would lengthen it. Scraping mass off the sides is not going to change the length. B would help because that would cause a change in length, which would increase. So it would specifically increase the length, which would give us a longer period or a bigger period.